Hello everyone, welcome back to my channel. I hope you all are doing well and learning mathematics with great enthusiasm. This video I am posting for grade 10 students in which I would start chapter 8 Introduction to Trigonometry. I would request you all please like, subscribe and share and press the bell icon for upcoming videos. So let's start our topic Introduction to Trigonometry. So first I would like to explain you about the word trigonometry. Trigonometry is a word which is derived from Greek words tri, gon and metron. Tri means 3, gon means sides and metron means measure. So trigonometry is a branch of mathematics in which we study the relationship between the sides and angles of a triangle. So hope you all know about the triangles, the bifurcation of triangle which we did in grade 9 as well. So what is a right triangle? Here a right triangle also you must be knowing. What is right triangle? Right triangle is a triangle in which one of the angle is 90 degree and rest two angles would be acute angles. In right angle triangle, you may see the side opposite to 90 degree is called as hypotenuse and the remaining of the two angles are called acute angles. On the basis of your consideration, we define its perpendicular and base. Suppose if you are here defining angle A, acute angle A, for it, this will be the opposite side and this will be the adjacent side. Or you can say for this angle, this is perpendicular and this is base, right? Similarly, if you consider the angle C, then for angle C, AB will become the opposite side or perpendicular and BC will become adjacent side or base, right? Now, we would define here trigonometrical ratio for acute angle. Always you remember T ratios of an acute angle in a right triangle, what they are expressing? They are expressing the relation between the angle and the length of the side. So it means the ratio is the relationship between this angle and the sides, right? Now to define trigonometrical ratios, we will take it one by one. As you can understand here, it is ratio. So first ratio we define as sine of angle A. Sine of angle A, as I told you, all the T ratios we define for acute angle. So either you can define for A or you can define for C. So first I am defining for angle A. How we define sine of angle A? It is side opposite to angle A divided by hypotenuse. So let's check what is the side opposite to angle A. Side opposite to angle A is BC and hypotenuse is AC. So we can write sine A is equals to BC by AC. Alright. And sine, we call it sine of angle A and we write it, this is abbreviation for sine, we write it SIN of angle A is equals to BC by AC. Understood? So this is what the trigonometrical ratio, first trigonometrical ratio, sine of acute angle. Next I would like to define here cosine of angle A. Cosine of angle A is defined as adjacent side of angle A divided by hypotenuse. So for angle A, adjacent side is AB and hypotenuse is AC. So how we will write cosine of angle A? Cosine of angle A will be AB by AC. So this is COS, cos is called the abbreviation for cosine of angle A. Next I would define tangent of angle A. Tangent of angle A, it's a T ratio which will be equals to opposite side of angle A divided by adjacent side of angle A. So for angle A, opposite side is BC and adjacent side is AB. So we define tangent of angle A as BC by AB and we write it tan A, we call it tan A and TA and tan is the abbreviation for the T ratio tangent of angle A. This you can remember in such a way like here one theme we can use for this: old Henry and his old art. So O I am using for opposite side, H I am using for hypotenuse, and A I am using for adjacent side. So first, that is sine, right? Sine angle A, how we define? Opposite by H. So we can understand from here, this is O by H. This is O by H. Alright. So sine theta or sine of any acute angle will be O by H. Similar way, cos of angle A, if you define, then it will come A by H, which is nothing but adjacent by hypotenuse. Similar way, tan theta or tan of acute angle you define, that is tan A will be equals to opposite by adjacent. So in this manner also you can remember. For the beginners it will be difficult to remember directly, so this kind of way you can remember the first three T ratios. So let's start for upcoming three T ratios. So the same triangle we are taking. Next I am defining here cotangent of angle A. This is called cotangent of angle A. Cotangent of angle A is adjacent side of angle A divided by opposite side of angle A. So for angle A, adjacent side is AB and opposite side is BC. So cotangent of angle A can be written as AB by BC. COT is the abbreviation for cotangent. So in short you can call this is cot A is equals to AB by BC. Next T ratio is cosecant of angle A, which is nothing but hypotenuse divided by opposite side to angle A. So hypotenuse is AC here and opposite side is BC here. So cosecant of A can be written as AC by BC, and cosecant of A can be presented as cosec A. This is the abbreviation for cosecant of any acute angle. Next we check the secant of A. Secant of A is called the sec of A also, and we write it hypotenuse by adjacent side to angle A. So hypotenuse is AC here, adjacent side is AB here. So we can observe this is coming secant of A is equals to AC by AB, and the abbreviation we use for secant of angle A, that is sec A. Alright, this also you can remember in the same the manner we took the straight way. Now when you go opposite, then A by O. If I write A by O, then it will come cot of angle A. So from here I can write cot of A as A by O. Like in the previous slide I have explained you, tan of angle A was O by A, right? So in this way you can go back. So suppose you want to find for sec is the reciprocal of cos. So you can see sec theta will come, sec of acute angle will come hypotenuse by A. So H by A. So when I go reverse, so sec A will come from here, H by A, hypotenuse by adjacent side. Okay, next we take cosec. So cosec we will see the reciprocal of sine. So cosec of A will come H by O. Alright, so in this way we define T ratios for any acute angle in a right triangle. So sine, cos, tan, cosec and sec and cot are the abbreviated form of sine, cosine, tangent, cosecant, secant and cotangent respectively. So if you have a triangle and you have to define here T ratios for angle C, then how would you take? For angle C, sine C, for angle C, the opposite side is AB, adjacent is BC and hypotenuse is same. So sine C will be opposite by hypotenuse. As you can observe, opposite is AB and AC is the hypotenuse. Similarly, this will be adjacent by hypotenuse, right? Tan C will be opposite by adjacent, right? Here cosecant C or cosec C will be hypotenuse by opposite, right? Similar way, secant of C or sec C will be hypotenuse by adjacent, right? And cot C, that is adjacent by opposite. So you can define the T ratios for both the acute angles. You have to check the angles and accordingly you can find the relationship between the angle and the sides of a right triangle. So reciprocal relation you can observe. Sine we have seen that it is coming opposite by hypotenuse, and cosec is coming hypotenuse by opposite. So what we can observe, they are reciprocal of each other. Or we can write cosec A is equals to 1 by sin A, or their multiplication is equals to 1. So these are called the reciprocal relationship amongst the T ratios. Next we have cos A and sec A. So when you define cos A, then you have written that it is adjacent by hypotenuse, and sec A is hypotenuse by adjacent, right? So we can observe they are reciprocal of each other, or sec A is reciprocal of cos A, and cos A and sec A multiplication is 1. Similar way we can find tan A is reciprocal of cot A, since tan A is equals to opposite by adjacent side, and cot A is equals to adjacent by opposite side, right? So they are reciprocal of each other and the multiplication is also equal to 1. One more observation we can do from here. Tan A, you can observe this is sin A, this is cos A. When you divide sin A by cos A, then you will get opposite by adjacent, so which is nothing but tan A. So tan A also can be written as sin A by cos A, and cot A also can be written as cos A by sin A. You can observe when you divide cos by sin, then you will get A by O, which is nothing but cot A. And here important thing, sometimes what we if we do the squaring or the exponent we find for T ratios, then how do we write? Sin A whole square we can write as sin square A. Also we can call sin square A instead of sin A whole square. Similar way, cos A whole square will be cos square A can be written, and tan A whole square can be written as tan square A. Similar way, sin A whole cube, instead of writing this or speaking this, we can write sin cube A. Also we can speak it sin cube A. Similar for cos A whole cube, we can write cos cube A. Tan A whole cube, we can write tan cube A. So next I would like to start the exercise 8.1 related with the T ratios. So first exercise, first question you may see, a triangle is given, triangle ABC, and right angled at B, where we have been given two sides and the T ratios has been asked. So let us make the solution for this. You can see that first figure we need to make here. So here B is a right angle, so I have made ABC a triangle, which is given here B as a right angle, and the other two sides AB and BC are given 24 centimeter and 7 centimeter. So with the help of Pythagoras theorem, first what we do, we find the third side. So what is AC square here? AB square plus BC square. AB substituted and BC substituted, we will get AC square as 625. So AC you will get 25 centimeter, AB you already have, BC you already have. Now sin A, for this angle you need to find the sine of the angle, right? T ratio you need to find. So for this will be the opposite side for angle A. First I am marking for angle A. This will be opposite side, this will be adjacent side, and this will be the hypotenuse. Now we already got hypotenuse as 25 centimeter. So let's see, opposite by hypotenuse, it means BC by AC, and BC is 7 and AC is 25. So we got the first T ratio, that is sin A. Similar way, cos A, if you find, cos A is this adjacent by hypotenuse, so AB by AC. So AB by AC, when you substituted this, you got 24 by 25. So next you have to find the T ratio for angle C. So angle C is here, angle C is here. You can observe this is here. Now what we have seen, sin C, for this angle C, this will be opposite, this will be adjacent, This will be hypotenuse, right? So angle C, we write opposite by hypotenuse. It means AB by AC this time. So AB by AC you will get 24 by 25. Similar way, cos C will be adjacent by hypotenuse. So adjacent side is BC by AC. So BC we have 7 and AC we have 25. So in this way we can calculate the T ratios for the given triangle. So let's take one more example. In the second question, we have given one figure. That figure you can see here. This is a right triangle, right angled at Q. Two of the sides are given. We need to calculate tan P minus cot R. So tan P minus cot R we have. So to find the third side, first we applied the Pythagoras theorem, and with the help of that we got the third side as 5, as you can observe the solution here. And then next we have seen tan P we need to calculate. The figure already I have made here. So tan P, for that P angle, this is opposite, this is adjacent, and this is hypotenuse. This opposite side we have got as 5 centimeter by the Pythagoras theorem. So what it will be, tan P will come opposite by adjacent. This means 5 by 12. So 5 by 12. For cot R, you can observe, for angle R, this will become the adjacent and this will become the opposite, right? So for cot R, we write as QR by PQ. So QR by PQ also will give you 5 by 12, and when you solve them, it will come 0. Okay, so next question I would like to discuss the question number 3. Here we have given sin A is equals to 3 by 4. We need to calculate cos A and tan A. So when you have some ratio, then we can find out the proportion side. So I have taken sin A is equals to 3 by 4. So it means BC. Suppose some angle I have taken here, angle A, for that I am defining, then BC will become 3K and AC will become 4K. Why? Because sin theta we know that this is nothing but opposite by hypotenuse, right? So we will find first the third side. For finding third side, we will use the Pythagoras theorem we used here, and we got the third side, which is nothing but root 7K. Next we see we need to calculate cos A. So cos A will be adjacent, which we got root 7K, right? So adjacent by hypotenuse. So adjacent by hypotenuse will give you AB by AC, which will give you root 7K by 4K. This K get cancelled. So you got cos A as root 7 by 4. Next we need to calculate here tan A. For tan A we can say angle A. For angle A we can say this is opposite and this is adjacent. So tan A will become BC by AB. So when we put the formula and we use the T ratio formula, then BC by AB will give you 3K by root 7K. This will give you 3 by root 7. Discuss the another question from exercise, that is 15 cot A is equals to 8 we have been given. We need to calculate sin A and sec A. So let's check what we have been given. Cot A is equals to 8 by 15 we have been given. It means for angle A, what we have, AB, that is 8K we have, and BC, that is the opposite side, adjacent side and opposite side ratio we have given. So this is given 15K. So first of all we need to calculate the third side with the help of Pythagoras theorem. You can observe here I have used the Pythagoras theorem, and the third side I got as 17K. Alright, now we have all the three sides, so we can find sin A. What would be sin A? Opposite by hypotenuse. For angle A, opposite is BC. Hypotenuse is AC, so opposite by hypotenuse is BC by AC. So when we will put the values, we will get the T ratio sin A. Similar way, sec A, if you want to find, that would be hypotenuse by adjacent, right? So hypotenuse is here AC and adjacent is here AB for angle A. So when we put the value AC by AB, it will come 17K by 8K, which is nothing but 17 by 8. Next, I would like to take one more question from 8.1. Here also we have been given sec theta is equals to 13 by 12, and we need to calculate all the T ratio this time. So what I would do first I will take a triangle, which a right triangle, which some angle I defined as theta, right? Now we have given sec theta, it means we have given hypotenuse and adjacent side proportion or ratio we have given. So we have taken that is 13k and this as 12k. All right, with the help of the Pythagoras theorem, I found BC, which is nothing but 5k. As you may be knowing about the Pythagorean triplet 5, 12 and 13, right? So we got the third side as 5k. This you can show by the Pythagoras theorem. Next, we need to calculate all the t ratios. So I would start with cos theta first. First, cos theta is the reciprocal of sec theta. Also, we know that. So what is cos theta here? AB by AC. So when I substitute, I will get the cos theta. Sin theta will be opposite, that is BC by AC. So BC by AC will give you 5k divided by 13k. This will give you 5 by 13. Tan theta will be opposite by adjacent. This is opposite, this is adjacent, and this is hypotenuse. You may write while beginning the questions, you may write, and then afterwards after some practice you may be knowing which one will be opposite, which one will be hypotenuse, and which one will be the adjacent side. So for tan theta it will be BC by AB, and when you put the value 5k by 12k, then you will get 5 by 12. Similar way, cot theta you want to find. So cot theta is just reciprocal of tan theta. That way also you can come. But here we write in the ratio. So AB by BC, right? Adjacent by opposite, cot theta, which will give you 12k by 5k is equals to 12 by 5. Next, I think I have missed here. So cosec theta, if I write, so what would be cosec theta? Cosec theta is the reciprocal of sin theta, as you can observe. So here we have hypotenuse by opposite. Opposite, what it is? BC here. So AC, what we have? AC we have 13 and BC we have 13k and BC we have 5k, right? So when you solve it, you will get cosecant theta as 13 by 5. So I hope you are understanding to calculate about the T ratio. I hope you are understanding how to find the T ratios, and this video will be helpful to you for understanding trigonometry. I would request you all, please like, subscribe and share, and thank you for watching my videos.